R. What's after R?
Q.
Very good. So I started programming when I was 7 years old. I was a little kid, and it was a lot of fun. This is 1985. You can guess how old I am. I'm actually probably younger than many of you. But anyway, I've been doing this for a super long time. What got me into programming was that it was fun. And it was, at that time, very easy because I used a Commodore 64 that used, BASIC. No, I'm sorry. A Commodore 64 was my second computer. First one was a VIC-20. Anyway, same BASIC. And it was super easy to do it. A couple of lines, a few characters, and I got going. And that's basically what hooked me on programming, was that it was fun and easy. So Dominic Tarr is our next speaker, and he's going to talk about fun and easy programming and distributed systems. Right?
Cool, thanks. Right, so I'm Dominic Tarr on the internet. My name is very good SEO, so just have a look on Google. Okay, so this is the part where people normally talk about the company they work for. I'd just like to take this chance to advocate for quitting your job. A lot of the great things that we have because someone quit their job. We have Node because Ryan quit his job and worked on it for 6 months. We have NPM. The most of that Isaac wrote when he had quit his job. I quit my job a while ago, and most of the stuff I'm talking about now is stuff I had done when I'd quit. And also, I made a great move 2 weeks ago. I quit my job immediately before I went to Node Dublin, and then I spoke about the stuff I'm going to tell you about, and then I met Nearform, and they had all the same problems I'd been working on, but they had people that needed to buy them. So they were like, "What if we pay you money to work on this stuff?" And I was like, "Fantastic!" So Nearform are cool. Okay, so I'm interested in distributed systems, which is also another way of saying real-time apps. They're all distributed systems because they're running on a bunch of stuff. So the original title of this talk was Distributed Systems for Kids, but distributed systems as soon as possible, or as simple as possible, is also a good way of putting it. So I'm talking about apps that, say, collaborative, work offline, and are as easy to build as single-user apps. Now, how the hell would you do something like that? So, need some volunteers. If you've got your computer ready, if you come to this address right there. Whoops. Okay, I can see that's working for some of you. Here we go. Yeah, here's a piece we should be working on right now. So it's a drawing app, and if you guys log onto this and have a scribble, that's fine. There we go. Thanks. Cool. So. This is a distributed system. Now, who could implement at least the single page part of this? Raise your hand. Like, really easy, right? Actually, everyone should be raising their hand because this is just like you click on it and it adds pixels. So we can make that distributed with like a few lines of extra code. Yeah. Okay. Okay. Any questions? Okay. If it's a Node.js question, the answer is streams. So this is just a quick aside, really. So this is how. So we have this model which has the distributors part, and we just connect it. So this is what it would look like if it was going through TCP. So from one node on server to another server-side node would look like this. So we get a stream. So this is also known as the duplex pattern. So you get a stream, you pipe it into something, and then you pipe it back to the stream it came from. Now, say this would connect to the server side, where we have we start a TCP server. When a stream occurs, we pipe it into our model, and then we pipe it back into the stream, and this thing connects to this thing, and then they communicate. So if we want to do WebSockets, it looks like this. So this is the client side. So we're using Shoe, which is actually wrapped by this thing called Reloader, which reconnects when there's a disconnection. Oh, sorry. Reconnect does that. Reloader restarts tells the client to reload the page if it reconnects and the code has and it's attached to a different version of the server. It's just like a dev thing. So this is what the server for that side looks like. So we just use Shoe, which wraps. You've heard of Socket.io? Who knows Socket.io? Don't use Socket.io. Socket.io is like, it's a good idea. It got us where we are. But everything in Node.js that does I/O does it with a stream. So if we're doing WebSockets, that's just I/O. So we want to do that with a stream as well. Shoe lets us do that. So we have to do this crap here to make it work, attach it to a HTTP server. It would be cool if it could just work as a middleware, but because of the way WebSockets fit into Node HTTP server, we can't do that. And there's this other thing too that's useful that I wrote called MuxDemux. Now it lets you put multiple streams through one stream, because sometimes you have a budget for how many streams you can have, like when you connect to, like through WebSockets. WebSockets is actually multiplexers for you, but some of the other fallbacks, like long polling, doesn't have multiplexing. So we'll just use this to put multiplexing back in, but give you, allow you to use the Stream API with very, very cheap connections. So this is what it would look, this is what you do. So you create a MuxDemux instance, you pipe it, attach it to the stream with a duplex pattern, and then you can create streams and you can receive streams, and then you can use the duplex pattern and put other models and interesting things through that. So that's just a diversion. Back to the thing. So what is this model part I'm talking about? So it's a commutative data type. So commutative just means that it doesn't matter what order the operations happen in. Like this, the value of this is 3. Now 3 is just the collection of 1 and 2 added together. So we want to build other things that, see the good thing about here, the fundamental fact about networks is that they're unreliable. So if you're sending messages around, you don't know what order, you can't guarantee what order they will arrive. So the old way was doing all this extra clever stuff, complicated stuff, to make sure that the order was reliable. But there's a much simpler way. Just make it so the order doesn't matter. And then then it's much more simple and easy and fun. Okay, so sets is another thing that's commutative. So if we're only adding things to a set, then it doesn't matter what order we add the things, we'll still end up with the same set eventually. So we've got guaranteed eventual consistency, which makes it easy to think about our application and know that it's reliable. So like tags are like one thing that's directly just like a set. But that's not that interesting. So we're just adding. Right. Then we can do some calculation on top of the set and get some property of the set that we're more interested in. Okay, so I'm going to show you another demo. Yeah. Okay, so this does a calculation on top of That's weird. Okay, so who's logged in at the moment? A couple of you? Can more people log in? So you're going to vote for your favorite node knockout speaker. So you can click on anyone, and it just like counts the yeah. And it just counts who has the most votes. So this, if the faces were all flying around shooting each other, then this would obviously be a game. At the moment, it's just yeah. Hang on. Very good. Okay. So here we're just doing a simple calculation on the set to get the winner. So we're sort of reducing the things to get all the sum of the counts, and then we are sorting it to get the top. So it's just that's pretty simple. That's easy. Anyone can do that. So another thing we can do is say we sort on a timestamp property. We just add properties to the objects in the set to make them more sortable. So if we add a timestamp, and then say we take the top one, the most recent thing, then we basically have a key value store, because we can just add a new thing to the set with a new timestamp, and now that will be the value of that set. Now, we don't really want to send all of the, we don't necessarily want to keep, just to get the value of a set, we don't want to send everyone the entire set. That's going to be bandwidth intensive. So what we can do is we can throw away the stuff that we know we're never going to need. So like the rest of the set, we can just like garbage collect everything that isn't the topmost thing. So I have a module that provides this for you. It's called Scuttlebutt. Now that sounds like a whimsical name, but that's actual science. I got that from a paper called, with some fancy name, that was invented by some Amazon people. So that's serious. But it's pretty simple, and it just gives you like a key value store that you can pipe to other things, and then you've got replicated data. But underneath, it's still basically a set. It still has the same eventual consistent guarantee. So, yeah. So what about arrays? Arrays are kind of the data structure we need, like all the time, really, for all sorts of stuff. But unfortunately, arrays have this problem where say I insert B at position 4, and simultaneously you deleted A at position 1, then if we try to apply those, the order matters. So we delete A, and then if we delete A and then insert B at 4, the B will be in the wrong spot. So it won't be consistent. Now or never. It will eventually be inconsistent. So arrays aren't commutative. But lists can be. We can make these commutative. So one thing is we have a whole bunch of objects. We have them a value, and we give them a sort property. And now this is just a key value store. So we can use the key value thing we built before, and then, but we'll do key value style updates to the sort property, and we'll just make it so that's a value between 0 and 1. And if you recall, between any two numbers, there's always another number. So we can just insert things arbitrarily at any points by just giving it smaller and smaller numbers. Now, if we used a real number, like a float for this, then you would eventually overflow. And that's not good. But if we just made strings that behaved like this, then it will work. So we can delete a thing from the set just by assigning its UID to null, and we can move it around by changing its sort field to between two other values. So I have a module for calculating this stuff called between, and I have this module that puts a whole bunch of that stuff into a thing that feels kind of like an array. It's called CRDT, which stands for Commutative Replicated Data Types. So it's basically like a framework for writing Trello, which is kind of fancy. Who's seen Trello? Yeah, so looks fancy, but easy. You can do that. So you can do text editing with this. You can make text editing commutative as well. Now, this is on my to-do list. Right, this isn't the only way you can build real-time apps, but it's but it's a very, very simple way, and it has interesting properties too. So it works very good with network partitions. Now, you get network partitions in all kinds of situations, like on the subway, no network, on an airplane, no network, tech conference, nearly no network. So it means by having commutative updates, you can send messages to any other node. Like, they don't need to go through a central hub. So you can just go crazy. Like, you can make peer-to-peer stuff oh shit, that's not right. Okay. Well, first time I've seen that bug, but we'll have to just ad-lib from here. So, yeah, this is my last slide now. Okay, so you can do like peer-to-peer stuff, and there's really interesting stuff on the horizon for doing directs, like phone-to-phone stuff. Like Android has a thing called Wi-Fi Direct, where so your phone can talk to someone else's phone immediately without logging into a hotspot or anything like that. So you could make apps that just work. Like, you could have a collaborative app that still works with other people on the subway or in the airplane. Of course, Bluetooth did that before, but Bluetooth's kind of crap. WebRTC is coming very shortly as well, and you can do peer-to-peer stuff with that. And other crazy stuff, like imagine like robots exploring the sewers of Paris. That's going to have a hell of a lot of network partitions. But one guy could go down one tunnel, another guy could go down another tunnel, and when they meet each other, they'll tell each other what they know. But they wouldn't, they don't need to, but they don't need to have seen that stuff themselves. But then once they know it, they can go off that stuff. So this is so this is my last thing. It is it's a local social mobile crowd-created platform for curating collections of animated dolphin GIFs. Oh, I've got to log out. So I figure, like, we have blogs, we have Twitter, we have chat, and they're all kind of different things. Why can't we just put them all into one thing that's the best of all of these things? So, like, blogs are great, but then comments are just full of idiots saying, like, stuff. But what if we added Twitter to that? So they can only type 140 characters. That would be a great improvement, right? And if people are writing stuff right now, you want to be able to see that they are saying, they're typing something, because then you might want to wait to see what they're going to say. And sometimes you say stupid things, and you want to say, you realize you've said something stupid. You want to say something clever instead. You can do that. And notice there's no, there's never any spinners, because it's all, the whole entire application is replicated entirely locally. Like I can even, I can kill the server actually it had crashed. Well, live demos is really hard. Anyone can write anyone can write production software. That's easy. This worked perfectly like 20 minutes ago. Here we go. Great. So if you paste a GIF, a URL to a GIF in there, that adds it to the page, but only dolphins, please.
Please.
Yeah. So yeah, they're good enough. Good enough. Yeah. So this is a new approach that I read about in science, but we can use it to build all kinds of cool toys and stuff like this. And the code I showed you for connecting stuff together is pretty much like all you need to add to make it just work easily. Like you basically just have, say the first example I showed you with your drawing. Like you could do that easy. You just click and you add, you're like, here's a pixel, here's what color it is. So imagine all you add to that is a timestamp. So you know if this pixel should go over another pixel or under it. And if you receive a more recent pixel, then you put it on top. So you just need to send those messages and collect them all at each node. That's all you need to do. Now you've got a distributed system, distributed collaborative system. Yeah, it's really easy. And you can use these other abstractions I've shown you as well. Okay. Okay, so I'm sorry I distracted. Working on node knockout. We've already started working on that. So I want to show you this crazy thing. Okay, that's my talk done. I just want to show you this crazy thing. Okay, we all knew and love abstract singleton proxy factory bean, right? Have you seen that? Yeah, there's a new one. There's an even better one. Okay.
It's at the top.
Look, internal frame, title panel, internal frame, title pane, maximizer button painter. This is why we use JavaScript, because we can make button painters way faster than this.
Leave that up for
Yeah. Okay. Yeah, I don't know what's going to ever beat this for worst class ever.
challenge accepted.
Yeah. Okay. This is in Swing. I bet you could probably find this might not be the worst one in Swing. Maybe there's other ones. Okay, cool.